Hey guys, today I wanna start talking about OCAF, which is OpenCascade Application Framework. And to give you some motivation right in the beginning, I have to say that this framework is pretty useful, and I also use it myself for 10 years or so. So we will start with OCAF Fundamentals to see what are the entities, what are the basic types of OCAF and how you are supposed to use it. Then we will switch to Object Interface Programming Pattern or Design Pattern, which can also be named as a data access object. And we will discuss at the end customization of OCAF, what are the extension points and how you can customize it to better suit your needs. If you remember, OpenCascade is not a single library, it's rather a composition of dynamically linked libraries, and subsets of those libraries are named modules. And OCAF is simply one of the modules, and probably it's not as popular as, for example, surface and solid modeling, but it's still pretty useful. And I would highly recommend you to have a look at this module, especially if you are going to develop your own desktop application, which is sort of classical one, like, SolidWorks, for example. So let's start with OCAF Fundamentals. And the main question here for me, and what I also want to start from, is to discuss what is the motivation behind OCAF, why it's there, and what are the problems it's supposed to solve. And the first question here is how to bridge this geometric modeling kernel with some real engineering applications, because basically it's not enough to have just a shape. Very often you need to associate some attributes, some metadata with your shape elements, like you need to have colors or product manufacturing information, tolerances, maybe some boundary conditions on your shape. And the problem here is that in OpenCascade boundary representation, which is pretty minimalistic, you simply do not have a room to store this sort of data. And this is where you can employ OCAF. OCAF comes with this application and document architecture, and there is also a bit of motivation to have this sort of architecture, because if you remember, OpenCascade is initially a geometric modeling kernel from Euclid CAD system, and this CAD system was a typical desktop CAD system where you have this document infrastructure, like you might want to have several studies, several documents in your session, and this thing is implemented in OCAF. It is typical for engineering application to organize your data in a hierarchical fashion. Like you put all your data chunks in a tree, and you might think that it's sort of very restrictive, but actually it's not. Because you can have one tree, which we would call a persistent tree, how your data is organized, and then you can also put different references and back references and relations between your data chunks, so that you can derive additional views on your data and, for example, build up derived trees or secondary trees or even graphs. Then, once you have a document with the hierarchically organized data, you might want to save it to file and open it back from file system. And this is where OCAF is of great help, because it gives you this storage and retrieval mechanics right out of the box. One of the standard features and typical features of a desktop application is to have undo-redo functionality. Like whenever you modify something in your data, you might want to roll back your modification and get back to the previous state of your data. And in OCAF we have this concept of undo-redo stack that allows you to collect different states or backups of your object and preserve this sort of linear history of modification. Then copy and paste. Since you have this hierarchical organization of data, it might be useful to copy one chunk of data and put it in some other location in your document. And transactional mechanism, this thing makes OCAF pretty similar to a sort of a database, and OCAF is kind of in-memory, no SQL hierarchical database engine. And you can have transactions in there, like imagine you run your algorithm somehow, and it throws an exception or it returns some invalid status code, and you might want to roll back to the previous consistent state of your data model. And thanks to transactions you can do that. So as I mentioned, we have one application that manages one or several documents, and each document is a hierarchy of labels, and each label contains attributes. So if you are going to work with OCAF, you need to be aware of those two notions. a label and an attribute. And the role of a label is twofold. Its main role is to address your data in the hierarchy, and that basically means that the label is just a tree node. And its second role is to contain the attributes. And your real data is distributed by attributes. In OpenCascade there is a huge set of standard ready-to-use attributes to store your shapes, triangulations, and also primitive types. But if you wish, you might want also to implement your own attribute, and this way to avoid the necessity to decompose your custom data onto the standard elementary chunks. Alright, here I am as usual equipped with Visual Studio and having this simple empty main function. Let's start to put some OCAF oriented code. So basically, if you remember, we need to have two things. We need to have application and a document. So that's why I'm starting from including these things from OpenCascade. And we have this package in OpenCascade which is named t-doc-std. It stands for Transient Document Standard. And here we have this application. What I'm going to do now is I'm going to create an instance of this application. And there we go. Now having this application, I can start to work with documents. So let's see if I can ask this application to create a document. Yeah, you see there is this new document thingy. And what it's supposed to accept is a format. And we will talk about format a bit later. So for now, let me just put here bin OCAF, which is like a magic, string. So I would suppose you take it for granted as of now, and we will discuss it. We will return to this subject a bit later. And then there is an outcome argument, which is t-doc-std document. That's going to be the document itself, and I'm going to declare it somewhere here. Let me call it like doc. And I do not need to allocate it from the heap memory because it's going to be automatically constructed by the application. So there we go. And now I can check that this document is not going to be null, because if it is null, then I have some problem. Let's put some error message here. And return error code. So I guess that's kind of enough. We can try to compile this small application. And yeah, you see that I'm in debug mode right now. And that means that I can put a breakpoint and try to trace the execution of this thing. So let's see what's going to happen. And also here I need to declare my project as startup project, of course. So finally I'm good to go. So you see that all the libraries of OpenCascade were loaded, and one of you asked how can we double check, how can we be sure that we have debug libraries loaded, and you can look here, you can look into this output console of Visual Studio, and you will see all the libraries, all the dynamically linked libraries loaded at launch time. And here we go, we have this tkernel library. You see it's coming from bin-d. And you also see a small hint here, like symbols are loaded. It basically means that you can navigate into the sources of OpenCascade and see how things actually work. So let's see what's happening here. We have this application. It has been created. We have this entity, which is of type t-doc-std application. It doesn't have any resources, and that's gonna be a problem, but not for now. And then we create a document. We have this document now. You see it has this storage format, which has been OCAF and something else. It's all executed successfully. So now we have this empty document, and you should always not forget to release your memory, because this document could be kind of heavy thing. It could contain a lot of data. So somewhere at the end, what I'm going to do is I'm going to close this document. Of course, our document right now doesn't contain any data, so it doesn't really matter, but that's just a good practice to follow. And now let's try to add some data. Let's try to store something in this document. And if you remember, a document is a hierarchy of labels, and it's not surprising that we have one label, one root label in the document, and all the labels, they are kind of numbered. Like you have a label with what we call tag. It's just an integer value associated with a label, so we have this label number 0, and we have underneath, we have another label, or we might create it if we do not have it. We have another label which is 1, and the full address of this label would be 0:1, and this is something called the main label in OpenCascade, so it has this conventional name, main label. Yeah, so there we go. I can put some decorations here. Yeah, so maybe this is a bit more clear. So what I'm going to do now is I'm going to access this main label and to put some attributes there. And here is what you need to do. So to access this label, I can go like document, then main, and you see it's going to return this TDF label, which is transient data framework label, main label. And now let's say I want just to attach an integer value to this label, and for that I'm going to use something from package tdata_std. So where is this package? tdata_std, that contains a bunch of predefined, bunch of standard attributes for different, primitive types in OpenCascade, and one of them is integer. And if I go there, you will see that this is a class which is inheriting from TDF attribute. And this is a base class for all OCAF attributes. So to have an attribute on my label, what I need to do, what I can do actually, is to go like tdata_std integer, which is the name of my attribute. And then I call a static method, which is set. And there I pass my main label and the value which I want to have there, like just some random value, why not? So what this method does, it creates a new instance of this tdata_std integer and attaches this tdata_std integer attribute to my main label. And if I want, I can also access this newly created attribute because it's returned by this static function, so I can go like attribute and do something like that, but actually I do not really care about this thing, so let me keep it like this. And one thing which I want to show you is how to inspect your OCAF document, because if you continue working with your OCAF document like this, using this bunch of setters and getters and drawing some, ASCII diagrams in your code, it's really going to be painful, and you need some tool to access your data. Just like when you work with a database, you connect to your database using some client, or you execute some queries in your admin panel, and we need something similar when we work with OCAF. So I'm going to show you how you can do this, and for that the first thing to do is to save our document to file. To do that, I need to use my application once again, and there is this method which is save as, and it's supposed to accept the document and also the file name. So I am just going to save my document onto my desktop. Let me call it test CBF. Make sure to specify exactly this format because it has some relation with this binOCAF thingy here. And CBF stands for Cascade Binary Format. So there we go, and this save as, it can return what is called PCDM status. You see this thing here. So let's have this persistent cascade document model store status. Let me call it like store status, S status. And then I can check that this status should be basically PCDM OK. And make sure it's not RS, it's SS here, because it's a store status. So if it's not OK, then it seems that I have some problem. And what I need to do, I need first to close my document, and then I can return 1 and put some error message like, I don't know, cannot write OCAF document for whatever reason. So let's see what's going to happen if I execute this modified main function right now. I'm going to I remove this breakpoint in the beginning, and I rather created a breakpoint here. You see that my Visual Studio is claiming that I'm using some unscoped enum, which is PCDM store status, and it proposes me to change it with some enum class, but it's a bit stupid because I'm not going to modify sources of OpenCascade, of course. So let's keep it like this, and let's run this whole thing and see what's going to happen. You see that we have this main label. If I go there to my watch, I see that this label has a tag 1, and it also has like a father, and this father has a tag 0. And this is the ultimate root in my hierarchy because its own father is 0. So it seems that I'm accessing exactly the label which I wanted to access, like 1, then 0. And then I set my attribute, and when I execute this save as thingy here, and you see that I have a failure, and this failure on save is one of the most typical problems people face when we start using OCAF for the first time. And the problem here is caused by so-called storage and retrieval drivers of OCAF, because OCAF doesn't have any predefined format how to serialize and deserialize your data. When we say that we want to save our document to a file with CBF extension, we assume that OCAF actually knows about this format, that it knows how to save our document to this format. And actually that's not true, because OCAF can save your data in different formats, and it's up to you to decide which format you want to use. And before, here in the beginning, we have specified this bin OCAF format. And that's the format which we really want to use. It's a binary format, it's a predefined format coming with OpenCascade. You can invent your own format, of course, but we are going to take advantage of what already exists in the library. And for that, we need to configure OCAF a bit more. So what we are going to do now is we are going to use these bin drivers. Like I want to register my storage and retrieval drivers in OCAF, so that OCAF becomes aware about this CBF file extension and its associated format, which is named bin OCAF. Before I save something here, what I need to do, I need to call this bin drivers define format, and then I pass here my application. And maybe it's better to call this static function not here, and rather right after we create our application. So once we have this application created in a heap memory, we also initialize it with a set of drivers which we are going to use. And let's see what is going to happen. Let me run this main function once again. And you see that now it's okay. So I do not have any problems with this document anymore. And if I go to my desktop, I see that indeed there is a file which has been created by OpenCascade. So it's pretty small, it's just 323 bytes. And if I open it with something like Notepad, then I see it's like a typical binary file. So it's not very readable, and I need to have some viewer, I need to have some tool to read and interpret this file. But before we go for such a tool, let me show you one other thing. Like, let me just, remove this instruction here so that I have a sort of an empty document. And let's see what is going to happen. I run it once again. And you see that the status right now is no obj. It means that you are trying to store an empty document, and it's sort of prohibited in OCAF. So if you want to have some file out of your OCAF document, then make sure that you have at least one attribute in your document. Alright, let's try to investigate what is inside this CBF document, because we need some UI tool, we need something which would allow us to debug, so to speak, our OCAF documents. And for that I'm going to use our familiar draw application. So what I'm going to do now is I'm going to run this draw application from here. And there is a module in draw which is OCAF, so that I can load it like pload OCAF, or alternatively I can load everything like we did before. And while we are here in the installation folder of OpenCascade, let me show you another thing which is pretty important to understand. Here, if I go to the sources, I do not see real sources of the library, because this is just an installation folder and it's not supposed to contain sources. But still I have quite some directories in there, and here I can search for this bin OCAF format, because that's exactly what we used in Visual Studio when we specify the format of our document. So let's see where it's declared. And you see that we have this folder which is StdResources, and there are quite some files in there, like this plugin and standard in XCAF. And if we go to this plugin file and open it, we will find here this bin OCAF document definition. So actually what is written there is that we have this bin OCAF format, and it's actually associated with the library which is tkbin. And tkbin is just a dynamically linked library of OpenCascade. So also here in the standard file we have this bin OCAF declaration. It's declared as an item in the format list setting here, and you see that this bin OCAF associates this CBF file extension with itself. As you might remember, I mentioned previously that these two guys are kind of attached to each other, and this attachment is realized by means of those two resource files. One of them is standard, where you declare this format and attach it to your CBF, and then also notice here that I have this definition right below. And the important thing here is that bin OCAF format is associated with a storage plugin and retrieval plugin. And there are two universal global identifiers in here, and those identifiers are used in the plugin file. So if I go here to the plugin file, I can easily find this identifier and this way to locate my dynamically linked library, which is responsible for both storage and retrieval. And this dynamically linked library is named storage and retrieval driver in OCAF. But that's not that important for us right now, because what I really wanted to draw your attention to is that this CBF format is not foreign to OpenCascade. And that basically means that I can try to open it here in Draw. So if I go here to OpenCascade official website, I can find here not only this piece of documentation about OCAF, which I have to confess I've never read, but I can also go to Draw Test Harness, and there are quite some commands of Draw which are specific to OCAF. So let's search for OCAF here. And you see that I can use OCAF, I can create documents using this Draw application, and I can also open my document using this syntax of open, then path, and then document name. So let's try to do that. So I'm going to name my document as doc. So actually I'm not quite sure what's happening here. You see that I received some error. So let me try to do this. Let me try to uncomment this thingy here, because I would expect that maybe because I commented this thingy out, my application attempted to save this file. It somehow saved something which was empty. So let me try to run this whole thing again. So you see that my process is complete and it exited with error code 0, which means success. And let me try to open it. Okay, so should I kind of run it again? Let me do this, pload all, and then I'm going to open my document to see users, user, desktop test cbf doc. And it seems to be fine right now. So it means that if I have an empty document, then I should be careful, because the file will be written anyways. But I will not have this pcdm ss OK status out of my application, and this file could not be read back. But okay, right now we have this document, so I can ask what is doc. And you see that doc is tdoc.std document. That means that this doc is actually a TCL variable, which is wrapping this tdoc.std document instance. And finally, what I really wanted to show you is this DFBrowse command. And if I pass here doc, then I have this TK window, which is basically just a browser for my OCAF document. Clicking here, I see that, okay, I have this root label, which is 0. It has a couple of attributes. It has this tdata.std name, which is a Unicode name of my document. I guess it simply holds like a file name of this document. Then we have this tdoc.std owner, which should contain something like back reference to my document. And finally, I have my tdata.std integer, which is located under the label 01 and holds the value which I wanted it to have. So this is how things work in OCAF. And there are quite some rules and quite some things to keep in mind about this whole OCAF story. But let's discuss all those specific points about OCAF in the next lesson, because I think it's enough for today and it's enough for you to get started with the framework. So I invite you to give it a try, and if you have any questions, then you have time to ask. Thank you and see you next time.